Assalamualaikum warahmatullahi wabarakatuh. A very good day to everyone. Hope everyone is staying safe and healthy in these quarantine troubling times. My name is Farhan Azri and my team and I would like to present our idea, which is the car safety sensor. The name will be changed in the future. Okay, if you all remember a few years ago, there were news articles about baby dying of suffocation due to recklessness of the parents. The said child was left in the car for a few long minutes by himself, unable to breathe. After that, countless articles regarding death in a car started popping up. Our product's aim is to try to make sure that such cases would not happen again. The details of the product will be presented by my team members after this. Firstly, I would like to show the draft planning of the car safety sensor. Okay, as shown in the slide, this is the whole draft planning until the actual product. Okay, the main focus today is for the idea drafting and proposal. The idea, this Gantt chart will be updated from time to time as every set objective or milestones are achieved. These are the few resources, but I act as the project manager, and these are the teams in my group. Okay, next I will pass to my team members to further continue the presentation. Thank you.
Hi, it's a good day to you and good day to everyone. Today I'm going to present problem statement. There are multiple recorded cases of death causes by heat stroke, hypothermia in cars after being left in the car on the hot days. The numbers of cases is on the rise worldwide in the recent years, while the case can be attributed to neglect. It is a very possible hazard on countries with high average temperature such as Malaysia, of which temperatures could rise above 40 degrees Celsius in enclosed space such as inside the stationary vehicles. Considering the risk, safety equipment for the monitoring and emergency notice can considerably reduce said risk. Okay, we go to the objective. The main objective of our project is to ensure the safety of passengers in vehicles when said vehicle is stationary from harmful conditions caused by neglect such as abnormally high temperature, and also to warn about the possible internal danger that requires immediate attention such as rising carbon monoxide concentration. That is our main objective of the product. So we're going to see the product that we are using this project, that is a controller which detect dangerously high temperature and carbon monoxide concentration, warning by means of GSM string or GPRS to trigger the application. User able to request data from controller for monitoring system.
Okay, now I will talk about the components that we have chosen. Here are the 4 key components. The first is the microcontroller. We chose the Raspberry Pi. The connection module, which we're planning to use the SIM900A. The temperature sensor, the DS18P20, and the gas sensor, MQ7 carbon monoxide. For the microcontroller, we have chosen the Raspberry Pi 3. This is because of the available Pi UI, which is the Pi user interface that comes with Raspberry. Compatible with SIM900A, it's capable of multiple information processing at once, and also capable of using the AWS, which is the Amazon Web Services, as data storage server, so we don't require our own servers. The connection module we chose for this project is the SIM900A. This one is capable of both GSM and GPRS, and since the communicated data are simply strings, thus GSM and GPRS provides enough speed. For the temperature sensor, we are using the DS18B20 temperature sensor. This one has a digital output which makes it compatible with Raspberry Pi, and it has innate high precision, more than we actually need. The objective of our device is to detect carbon monoxide for carbon monoxide poisoning. So the sensor for that purpose is the MQ7 carbon monoxide specific sensor. This sensor is specific to detecting carbon monoxide and is also made to be used in cars. However, the MQ7 requires an analog output, which requires an ADC for the Raspberry Pi to interact with. The last key component of our device is the power supply, and we are using a rechargeable power supply which recharges with power generated from the engine. We would also like for the power supply to be augmented with solar if possible, but the design for that will be reserved for high-end products in the future because it will incur cost problems.
Hi, my name is Najib. I will continue our presentation with limitation of the project. The first thing is power supply. We are using power bank as a power supply. The problem is when the power bank runs out, it is hard to charge the power bank. The capacity of the power bank normally is 10,000 milliampere hour. The normal time to charge it with 2 ampere charger will take 5 hours. But if we charge it using USB car charger, it will take 20 hours to complete because the output current is only 0.5 ampere. Second is carbon monoxide sensor. These sensors are require manual calibration for any practical use. Without calibration, this might turn on alarm in clean air or not detect carbon monoxide concentration. The last thing is SIM connection module. The problem with this part is not the module, but the problem is with the SIM. We need to top up the credit once a month, and we need to check the internet quota manually using the apps. That's all. Thank you.
Hi, my name is Shahril. Okay, I'll present about the flowcharts. So for the general flowchart, there will be 4 processing blocks. And the first one, when the car windows is closed, and the sensor will detect and it will turn on the buzzer. The driver need to do some response by opening the window. Okay, for the second flowchart, when the car window is closed and the driver or passenger did not respond for 15 minutes, the system will automatically send source message to other recipient. There will be 2 sensors that will be operated in this system, which are temperature sensor and carbon monoxide sensor. When the temperature sensor detect heat which more than 35 degrees Celsius in the car, it will turn on the buzzer in order to gain attention from the outside. Same goes to the carbon monoxide sensor, which will also detect the presence of carbon dioxide which is more than 35 ppm, and it will turn on the buzzer. The driver or passenger need to respond by open up the window. If there is no response from the driver or passenger, the buzzer will keep repeating to alert the surroundings. That's all from me. Thank you.
Now I will present the financial plan for this product. First of all, we are making this product with 2 key assumptions. The first is that the product has a 5-year commercial value until sales are negligible. And the second one is that the sales will increase compoundly by 20% for the first 2 years, and then 10% a year until the prices drop. What we have on screen right now is the quantity analysis for the manufacture of the product. I would like to bring your attention to 2 key points in this table, which is the quantity and also the profit. Using the information from this table, we can find the break-even point where we start making profit. We see that the break-even point is at 44, where we start making a profit of 59 ringgit. Here is the analysis represented in graph form. As you can see, the intersect occurs exactly at the 44 mark. On display is the monthly break-even analysis. The monthly unit break-even, as we have just found out, is 44 units. Monthly revenue for break-even is 22,000. These values are calculated with the following estimations. We have a per unit revenue of 500 ringgit, per unit variable cost of 294 ringgit and 10 cents, and an estimated monthly fixed cost of 9,000 ringgit. Now we go forward for the projected sales of the product. For years 1 and 2, we can see on screen that we have an increase in the total sales. Going into year 3, we estimated the sales to be somewhat similar to year 2, and year 4 for the sales to go downwards. The decrease in profit is even more prominent in year 5 due to the increase in cost over the 5 years. Here is the pro forma profit loss for the product. The key item here is the return on investment, and we can see the return percentage decreases over the year and takes a massive dip in the 5th year. Here's the estimated development cost for the product. The labor cost for the duration of the development is around 52,000 ringgit. The materials, 17,000 ringgit. The prototype itself, around 300 ringgit, which would make the total development cost be 69,300 ringgit. On this graph, we can see the quantity analysis for the whole project. From the graph, we can see that we make actual profit from the project in the middle of the 1st year. That is all from us. If you have any question, feel free to ask the member in charge as listed here. Thank you for watching.